Hello guys, and welcome back to another episode of chemistry. Of course, today we are going to continue our study on chemical energetics, and we are going to continue with studying what enthalpy. Today we'll talk specifically on what on enthalpy. We call enthalpy heat content of a substance. Heat content of a substance is what we refer to as enthalpy. Okay, so but before we begin, let us take a question from the O3 School JAMB app to let you know that, of course, these questions are expected. Okay, so if I give you a question like this, it's being displayed on your screen right now. This is a 2011 question, number 27. All right. They say in the diagram above, X is the, okay, you can see X clearly there. So what is X there? Okay, so if you do not know anything about enthalpy and you do not know anything about energy profile diagrams, okay, it will be difficult for you to answer. That's why your exam is a CBT exam. So you need a JAMB CBT app like the O3 Schools JAMB app. Okay, I'm going to talk about the app later, but head to Play Store right away. Pause this video, head to Play Store, download the O3 Schools JAMB app with the logo you are seeing, okay, on this screen. Okay, now let's go back to enthalpy quickly, and then we'll come back to this question and many other more questions. We'll come back to this question and many other questions before the end of the class. Okay, so please stay to the end of the class. We are not supposed to be skipping videos or jumping or watching half-hour videos. You are doing yourself, all right? So you have all you need on this channel and what with that app. If you have that app and you see you follow our classes here, you'll be very, very fine. You'll give your testimony. People have given their testimonies over time, so your case will not be different. Okay, so enthalpy. We say that what enthalpy is enthalpy. Okay, is same as what? Heat content of a substance. Okay, we say enthalpy is same thing as what? As heat content of a substance. And we define enthalpy or heat content of a substance as the amount of energy, a substance possesses internally, okay, of a substance is defined. Let me just define it. It's defined as the amount of energy a substance possesses internally owing to its structure. Okay, enthalpy or heat content of what of a substance is the amount of what energy that substance possesses, okay, internally owing to what? To its what structure. Okay, so now it is very important to note that what as the total heat content of what of the reactant in the reaction is different from the total heat content of the product, then that means that what something must have happened along the way line. Before we continue, it is important first of all to know that the total heat content, if you have a reaction like this, A plus B, okay, they give you C plus D, okay, the total heat content, okay, the total heat content of this what reactant is different from the total heat content of what of the product, okay, because what along the reaction, during the pathway of the reaction, you know, the energy profile is what shows you the pathway that a reaction progresses as it goes from what, from reactant to what, to product. All right, so now as this reaction goes from what, this reactant to the product, some energy will be lost, some will be absorbed. Okay, irrespective of the one that happens, it means that what the total heat content for this reactant will be different from the total heat content of what, of the product. Okay, so now as the total heat content of the reactant is different from the total heat content of the product, that means that there must have been something that has happened along the way line. Okay, because it is this reaction, this A plus B, that gives rise to what, C plus D. Now, and we are saying that the total content of this reactant is different from the total content of what, of this product. That means that something has happened along the way line. Okay, something has happened along the way line. You were sent to go and buy barbecue fish. Okay, before you got home, before you took it to who sent you, tail is missing or head is missing. That means between when you bought the fish and between when you got to where you are supposed to deliver it, you have done something to the fish. All right, that means that something must have happened, okay, for the total heat content of the reactant to be different from the total heat content of the product. And what must have happened may be what? Absorption, absorption or liberation of what? Of heat. Okay, that means that what? It's possible that what? Energy must have been what? Gained, or heat energy must have what? Must have been liberated or released to the surrounding. So that's why we are saying that as the total heat content of the product, or sorry, of the reactant is different from the total heat content of what? Of the product. That means that what? There must have been absorption of heat or what? Liberation of heat to the what? To the surrounding. We get. So now, when absorption of heat happens, when heat is absorbed, okay, when heat is absorbed, it means that the total heat content, please note this, when heat is absorbed, it means that the total heat content of the product is greater than the total heat content of the reactant, right? Let me put that down. When heat, it is what? Is absorbed, okay, it means that what? That the total heat content of the product, rather, of the product is greater than the total heat content of the reactant. Okay, so now when heat is absorbed, okay, it means that what? That the total heat content of the product is greater than the total heat content of the reactant. This is reactant. Okay, these are the reactants, and then these are what? The products. It means that the total heat, when heat is absorbed, okay, it means that the total heat content of what? Of this product is greater than the total heat content of what? Of the reactant. Okay, and therefore we now say that that reaction is what? Is endothermic. Endothermic. Okay, so a reaction where heat is absorbed, okay, from the surroundings, called what? An endothermic what? Reaction. That's the kind of reaction. So a reaction where heat is absorbed, where you receive heat, you collect heat, okay, that is called what? An endothermic what? Reaction. Okay, so now on the other hand, when what? Heat is liberated to the surrounding, when heat is liberated to the surrounding, it means that the total heat content of the product is lower or less than the total heat content of the reactant. Now let us see that. When heat is released or liberated, when heat is released or liberated to the surrounding, it means when heat is liberated to the surrounding. What does this mean? It means that what? That the total heat content of the product is lower than that of the reactants. Okay, so in the first case, we said when heat is absorbed, and we say when heat is absorbed, the total heat content of the product is greater than the total heat content of the reactant, or the total heat content of the reactant is lesser than the total heat content of the product. Hope you understand. When heat is absorbed, the total heat content of the product is greater than the total heat content of the reactant. It also means that when heat is absorbed, the total heat content of the reactant is lower than the total heat content of what? Of the product. That means total heat content of product is greater than total heat content of what? Of reactant. Okay, now when heat is liberated to the surrounding, we say that the total heat content of the product is lower than the total heat content of the reactant. That means that the total heat content of the reactant is actually greater than the total heat content of what? Of the product when heat is what? Is liberated to the surrounding. Now, the change in heat content is the next thing we should now talk about, and that is what we call the delta H. The change in heat content. That's what delta H. Okay, this delta H is equivalent. We say it's equivalent. It's equivalent to the energy lost or gained during the reaction. Okay, so now the change in heat content, delta H, okay, we say is what? Is equivalent to the energy lost or what? Gained during the what? The reaction. We're going to see how we calculate that mathematically very soon. Okay, so I'll go over that again. Okay, but before I continue, please make sure you have liked this video. If you're not liking this video, what you're doing is very, very wrong. It's very, very wrong. All right, because liking the video will make other students to easily find the video, and you want them to pass like you. So please like the video. As you're watching the video, you can just click on that like button like this. Then also do not forget to subscribe to this channel. Subscription is free, FREE. It means that whenever we release a new video, you get a notification on your phone. Is that one not good? It is good. Okay, so please click on the subscribe button immediately now as you're watching, and do not forget to keep sharing. Okay, so I'll go over this again. From the beginning, we said that enthalpy is what? Enthalpy or heat content of a substance is the amount of what? Energy a substance possesses owing to its structure. And we said that what? That the heat content, okay, of the reactant is usually in a reaction is usually different from the heat content, from the heat content of what? Of that of the product. And because there's a difference, that means that what? Something must have happened along the line, which could be what? Absorption of it or liberation of it to the surrounding. Okay, and we said when heat is absorbed, okay, from the surrounding, we say that kind of reaction is called an endothermic reaction. When heat is absorbed, we say that kind of reaction is what? It's endothermic. But when heat is liberated, we say it is what? It is exothermic. When heat is liberated, we say it is what? It is what? It is exothermic. Okay, so now when it is absorbed, it means that the total heat content of what? Of the product is greater than the total heat content of the reactant. Okay, and then we say that reaction is what? It's endothermic. But when heat is liberated to the surrounding, it means that the total heat content of the product is lower than the total heat content of what? Of the reactant. Okay, and we say that kind of reaction is what? Is exothermic. Okay, and then we say the change in heat content. The change in heat content, as you can see, delta H here, is equivalent to the energy lost or gained during the reaction. Okay, now that we know that, it is also very important to know that whether a reaction is endothermic or whether a reaction is exothermic, right? All reactions require a little energy input for the reaction to begin. You get that? Whether the reaction is exothermic or the reaction is endothermic, all reactions require a little energy input, okay, for the reaction to begin. And after that little energy input has been gotten, all right, the reaction can now proceed, and there can now be what? Net flow or gain of what? Of energy. All right. So it's very important that before a reaction, when you see A plus B equal to C plus D, before that kind of reaction will begin, it requires a little what? Energy input. It requires a little energy what? Input. Okay. So after it has gotten that energy input, then it can now what? There cannot be what? Net flow or gain of what? Of energy. Okay. So now for endothermic reaction, for endothermic reaction, okay, where what? Heat is what? Heat is gained, right? Where heat is gained. For endothermic reaction, where heat is what? Is gained, okay, or absorbed, okay, the change in what? In heat content is what? Is positive. Okay, now take note of that. For endothermic reaction, where heat is gained or where heat is what? Is absorbed from the surrounding, the change in heat content is what? Is positive. Take note of that. Now for exothermic reaction, on the other hand, okay, where heat now is what? Is liberated. Where heat is liberated, comma, the change in heat content is what? Is negative. Okay, you must take note of that. All right. So for endothermic reaction, where heat is absorbed, the change in heat content is what? Usually what? Positive. While for exothermic reaction, where heat is liberated to the surrounding, the change in heat content is usually what? Negative. Okay. So now we can calculate mathematically. We can mathematically calculate what the change in what? In heat content, okay, of a what? Of a reaction. All right, let's quickly see now how to calculate the change in heat content of a reaction. The change in heat content of a reaction. All right, so now it can be calculated mathematically as follows. What we have that change in heat content is equal to what now? H product minus H reactant. okay, where H product, or what we call HP now, okay, is what is the heat content of products. And of course, H reactants, that's HR now, is equal to what? Heat content of reactants. All right, so this is how we calculate what the what to call what the change in heat content of what of a reaction. Okay, so we say what change in heat content is what is H product minus H reactant. That is where H product is what heat content of the product, and where HR is what heat content of what of the reactant. Okay, so in other words, we can say that delta H now is what is HP minus what? Minus HR. That is what? Change in heat content of the product minus what? Change in heat content of what? Of the reactant. So let's quickly see an example. Let's see an equation. Let's see a small equation. Should I have cleaned this? No. Okay, but let's see. I'm sure you understand the formula, right? We're going to apply it right now. Let's see an equation. A plus B giving you C plus D. A very simple reaction, of course. Okay, let's say, for example, we have what? Heat. Let's say the heat is what? Is 5 joule. Then plus, of course, A plus B. These are the reactants. Okay, reactants. And let's say it's 10 joule. Then to give you, for example, C plus D. This one is product. Okay, and let's say the total heat content of the product is 15 joule. Okay, so I give you a reaction like this. Heat, this is the minimum what the little energy input that is required for the reaction to what to proceed. Okay, so now I'm giving heat 5 joules. They are giving A plus B, the reactants, the total heat content of the reactant here is what is 10 joules. Then here the total heat content of the product is what is 15 joules. Okay, so now to calculate what change in heat content, that is delta H now will be equal to what now? H product minus what? H what reactant, isn't it? From our formula we just seen. Okay, so now what is HP? Heat content of the product is what? Is 15 joules. So which is give us that delta H will be equal to what now? 15 joule minus what? 10 joule. Okay, 15 minus 10 joule is what? Is 5 joules. Okay, 5 joule, is it positive or negative? It's positive. So because it's positive, that means what? This reaction is what? Is it endothermic or exothermic? What did you say? You said what? Yeah, it's endothermic. Because what? The change in heat content is what? Is positive. I say that when the reaction is what? Is endothermic, that is where heat is what is absorbed. The change in heat content is what? Is positive. Okay, that means that what? This is an endothermic reaction. Okay, it's as simple as ABC, because what? Heat is what is absorbed here. Okay, let us see another example. Another example. Let's say, for example, now we are giving A plus B, and let's say it's what? Is 20 joule. Okay, then now gives us what? C plus D. Okay, then plus energy. Okay, let's say if energy is what? Is 5 joule, and then C plus D is 15 joule. Okay, now if I give you this reaction again, and then we're told to what? To calculate the change in heat content of what? Of this reaction. It's as simple as ABC. We employ our formula HP minus HR again. So delta H is what? Is HP minus what? HR. What is the heat content of the product? The product, this is the product, C plus D, which is what? 15 joule. Then minus what is the heat content of the reactant here? Is what? 20 joule. Okay, 15 minus 20 is what? Is minus 5 joule. Minus 5 joule. Okay, because what? The change in heat content here is negative. That means that what? This reaction is what? Is exothermic. Okay, this means that this reaction is exothermic. It's as simple as ABC. You see, right? So this is how we calculate for the what? For the change in heat content of what? Of a reaction. All right. So now the next phase we are going to go into is what? Is knowing how to what? To draw energy profile diagram for both what? Endothermic and exothermic reactions. Okay, so the importance of the energy profile diagram is to show us theoretically the pathway. Okay, a pathway for what? For a reaction as it progresses from reactant to what? To product. Okay, so that is the usefulness. It's what? It shows what the course, right? It shows what the course. It shows the path that is what? That it takes. Okay, and tells all the what the minimum amount of energy that's required before the reaction can work and take place, the activation energy. We're not talking so much about activation energy because in the next episode we'll be dedicated fully to talking about activation with energy. So now we're going to see energy profile for a reaction. Okay, so for endothermic reaction, yeah, endothermic reaction. So to draw the energy profile diagram for endothermic reaction is very easy. All right, so I'll show you something simple. All right, show you something simple. So you have something like this. Okay, then of course let's say here is 0. Okay, this is the reaction pathway. Reaction pathway. All right, then this is, let's say here is what is 1. Here is 0, here is 1, here is 2, here is 3, here is what 4. Okay, this 1, 2, 3, 4, they are called the energy levels. Energy levels. Okay, then of course, all right. Okay, so this is what the profile diagram for what, for an endothermic reaction. Okay, so of course you can dot here. All right, then we have something like this. Okay, why this from here to here is what is change in what, in heat content. Okay, which is what is positive. The change in heat content for an endothermic reaction is positive. This is the what, the activation energy. All right, why here is the activated complex. All right, so it's as simple as A, B, C. Okay, so it shows us what the change in enthalpy. The energy profile diagram shows us the change in enthalpy, and then it shows what the activation what energy. All right, and then look at, yes, this point is what is the activated what complex. So this is the what energy profile diagram for an endothermic reaction. You can see how it started. It started from a lower point, then it doesn't what get to what, to this lower point. Okay, you get simple, very, very simple. So it starts from a lower point. Okay, that's why it's good to number it in case you do not, in case you be confused how which one it is from. Because if you see the one for exothermic reaction right now, you may be even confused. Are these two not the same? But they are not what, the same. So you must know where the diagram starts from. So this one starts from somewhere like 1, and then goes up high, and then it doesn't what get to what, to this one again. Okay, it goes this way, it branches off. So this is what the energy profile diagram for an endothermic reaction. Please draw it down on your notes. It's very important. You must know that yes, what is change in what, in heat content. Okay, or the enthalpy. Now I don't think there will be space. I've drawn the that of the exothermic here. So now let us take this off the board. This is for endothermic reaction. Now for exothermic reaction, we have, please, if you have not liked this video, just click on the like button immediately. If you have not subscribed, subscribe, and of course keep sharing what these videos. Okay, so now we have something like this. All right, then the same thing, 0. This is the reaction pathway. All right, so that's the reaction pathway. Then you can number to make things easy for you. Just number. So here is 0, that means here is 1, and here is what is 2, here is 3, and here is what will be 4. Okay, so the one for what, for exothermic reaction starts from somewhere like 3, then goes up and comes down to 1. Okay, so I'm going to have something like this. Then you have something like this. This is one for what, for exothermic reaction. Energy profile diagram for exothermic. Okay, why the change in heat content appears here, from here to here, somewhere from here to here. Okay, that what H is what, minus what is negative. The change in heat content for what, for an exothermic reaction is what, is negative. Okay, then of course here is our activation energy from here to here. Activation energy. What does not change, of course, is the activated complex. Okay, so then we have what, our change in what, in enthalpy there. So this is the energy profile diagram for what, for an exothermic what reaction. We have seen the one for endothermic. This one is one for what, for exothermic. So we're going to go to the O3 School JAMB app. Like I said, it is all you need to succeed in your exam. It has all the past questions you can ever imagine, and then it has some wonderful features for all subjects, past question for all subjects. So you don't need to go and buy past question outside 115 for 4 subjects. That is 6,000 naira. Okay, with just 3,000 naira, you get this app activated. Just 3,000 naira. As at the time of shooting this video, it will increase in the future, so that you'll not message me in 2000 and say that I've got a video and you say it's 3,000. It will increase. Things will increase. All right. Now, let's take some questions. So you get the app, download it from Play Store, and then of course you need to activate. Okay. One other reason why you should get this app is UTME challenge. You need to be consistently participating in mock exams. So we conduct mock exam every Saturday morning by 10 a.m. Okay, to test how prepared you are. So you compete with your mates, you win prizes, you get used to our JAMB set question, you build your confidence toward the main exam. Your results will be released every week Saturday also, so you're able to track your progress of preparation. You need this app. To activate, click on activate on the app after downloading it. At the top, you find buy activation key. Then you see options for activation. You can use your debit card to pay. You can transfer to the O3 School app account. And if you need this application, the software version, if you need for your laptop or computer, just send a message to this number 09121515246. Send a message to this number on WhatsApp. You get the link to download for the PC. Okay, but if you want to download for your phone, go to Play Store. It's in Play Store. Now let's see that question again. 2011 question number 27. 2011 number 27, and it says, in the diagram above, X is the, as you can see, X is the, all right. So obviously, this is not an endothermic reaction. This is not an energy. This is not the energy provided for endothermic reaction. Okay, it's more of resembling an exothermic reaction. Okay, so and they say that the where is labeled X? Where is labeled X? There is what? Is it the A, enthalpy? B, is it enthalpy change? C, is it activation energy? D, is it activated complex? This is where activated complex is. This is where activation energy is. Okay, and of course, this is enthalpy change. It's not enthalpy, because there's change. It's change in enthalpy. That's why we are seeing this change here. It's change in enthalpy, not just enthalpy. Okay, so the correct answer there will be change in enthalpy. Change in enthalpy. Correct answer will be option B. Now let's see another question. 2011 number 31. 2011 number 31. It's been displayed on the screen. When delta H is negative, the reaction is said to be A, they said ionic, B, reversible, C, exothermic, D, endothermic. And I'll say that when heat is liberated to the surrounding, okay, the total heat content, the heat content of that reaction is negative. That's what it is, exothermic. Okay, so when delta H is negative, we have an exothermic reaction. That's our answer. There will be option Option C. All right, I see the way we are choosing question because we have read. Okay, now this is a 1999 question number 30. They say the entropy and enthalpy of a system are a measure of, I know I've not done entropy yet, I'm going to do it. Okay, so the entropy is the degree of disorderliness or jaga-jaganess. We call it the degree of scatterness or jaga-jaganess of a system. How scattered, how disorderly a system is. That is entropy. Entropy. Okay, that is one we call entropy. How disorderly, how jaga-jagally, how scatterly, right, a system is. Okay, that's what the entropy. And they say the entropy and enthalpy of a system are a measure of A, degree of disorderliness and heat content respectively, which should be the very correct answer. B, they say heat content and degree of disorderliness respectively. C, they say heat content of a system only. D, degree of disorderliness only. So you can fail this question even if you know it. You can fail it because if you choose B, you'll be very wrong. Because the first one, they say the entropy and enthalpy. They not say the enthalpy and entropy. So that means for the entropy first, which is degree of disorderliness, before the enthalpy, which is the heat content you get. So if you go and choose heat content first, okay, you will fail it. So that's why you need to know how to answer JAMB questions. You must know how to answer JAMB past questions. Okay, that's why you go and download this app now. All right, download it and practice with it like your life depends on it. You see how you will smile that day. Now let's see a 2022 question. This is a 2022 question number 29. It says energy changes occur in A, physical reaction. B, chemical reaction. It's a chemical reaction. I think we did this in the last class. All right. I wasn't meant to talk about that. All right. So that is, those are the few of the questions we're able to draw from the app. There are thousands of other questions on the app. Go download the app, activate it, and start practicing immediately. Like the video, subscribe, and keep sharing. My name remains Master T, your favorite chemistry teacher, and I'll see you in the next episode. Thank you for watching.